Hello, ladies and gentlemen, and welcome back. We're continuing our look at the grade 7 Gauss from the year 2003. We're up to question number 20. So 6 points, A, B, C, D, E, and F, are placed on a square grid as shown. Okay, A, B, C in the top row, D, E, F in the bottom row. Very nice. How many triangles that are not right-angled can be drawn using 3 of these 6 points as vertices? Okay. Not a bad question. Not a bad question. That's probably why it's question number 20. Alright, so what can we do here? Well, we can get some triangles. For example, ADE. That would be a great triangle, but that's going to be right-angled at D, and that's one of the ones that we don't want to count. Okay. So, I have to choose 3 vertices to make a triangle. First thing I note is that I can't choose all the numbers on either the top row or the bottom row. If I choose ABC, that's not a triangle, that's going to form a line. Same reason I can't choose DEF. Okay. So that means that I can't have all my vertices on the top row or the bottom row. I have to have a bit of a mix. So I can either have 1 vertice on the top row and 2 on the bottom, or 2 vertices on the top row and 1 on the bottom. Okay? How about we just do a little bit of investigation by saying we're going to have 2 on the bottom and 1 on the top. Okay? And we'll see which triangles. Can we get any triangles that work? I noticed 0 is a potential answer. Now with questions like this where we're trying to count, I tend to guess that the answer is going to be sort of on the high end. And the reason I guess that is because it's very easy to undercount. That can sometimes be the tricky point here. So here are points A, B, C, D, E, and finally F. So notice the vertices we choose. Can't all be on the top or the bottom. So to investigate, let's look at triangles with 2 points on the bottom and 1 on the top. All right. So, when it comes to choosing our top point, no reason not to take a look at A. So we could have A and then D and E. That's a possibility. We could have A, D, and F. Or finally, we could have A, E, and F. Okay. And when we form these triangles, we see that the first 2 are right angles, or have right angles at D specifically. And these are the only ones we can form with A and two of the 2 other vertices on the bottom. But AEF, we can check. No, it's got a very large obtuse angle here, no right angle at all. So we've got one that works. So at least there is one that we can count. That's great. Okay. Well, suppose our top point wasn't A. Maybe it's B. Well, we could have B, D, and E. Or we could have B, D, and F. Or we could have B, where is it? E and F. Now, two of these are quite obviously right angled, but this third one is also right angled, and it's really hard to tell. If you need to see it, realize, for example, that this is 2 unit lengths over here, and if we draw in C, for example, 1 unit length, 1 unit length, by Pythagoras is going to be root 2. This one's going to be root 2 here, and root 2 squared plus root 2 squared. Root 2 squared is 2, so 2 plus 2 is 4, which is 2 squared. So this is actually a right angle in here. So none of these work. If our top point is C, well, it's going to be exactly the same thing we saw in the first case with A, only flipped around. So we get one that has an obtuse non-right angled triangle. And then we're going to get a bunch of right angled triangles. But these are exactly the same triangles we saw on the other side with A. They just flipped around. And we can get a similar situation by flipping these ones not across a vertical line, but across a horizontal line. Then we'll have triangles with 2 points on the top and 1 on the bottom. So we could make an argument about flipping, but really this didn't take that long. We exhausted all our possibilities. Suppose now 2 points on top and 1 on bottom. Okay. Now, if you can see the symmetry argument, if you can see the reason why at this point we know that there's just going to be 2 in our third category, because we had one that we cared about here and the one that we cared about on the other side. So we got 2 when there were 2 points on the bottom and 1 at top. If you can see sort of the flipping argument that one would want to make to say, well, there's going to be 2 more if the 2 points are on the top and 1 on the bottom, it's going to be a flip of one of the 2 triangles we already saw, giving us 4 triangles in total, that's fine. If you can see it, that's great. It's multiple choice, so no one's actually looking at your solutions or your rough work. And at that point, you would bubble in 4 and move on. But if we need to see it, if we need to confirm it for ourselves and make extra sure, no reason not to. The first half didn't take us that long. Let's finish the question off. So 2 points on top, 1 on the bottom. Let's suppose that 1 point on the bottom is D. Well, what could we have on top? We could have A and B be our 2 points on top. Okay, but we've seen a triangle like that before. We could have A and C. You'll notice that this is taking a lot longer, and it's a lot less elegant. If we could, we would really like to have had a symmetry argument. And so that's something that you can practice on your own. But here we have another one that we care about. We could have E be our point on the bottom. But that's going to be very similar to the B case we saw before. We're going to get a sneaky right angle triangle here. Okay? You might think it's obtuse. You might think it's not right angled. But you got to go through and double check it. Because that's why we have a 6 in our possible answer. The C right here is 6. Because if you're counting DBF as non-right angled, even though it is, you're going to get DBF and AEC. And those are going to give you a total of 6. So you got to be careful. You got to make sure that these either are or aren't right angled triangles. Okay. But this one here, for the same reason, is going to be right angled. And BCE is also right angled. And finally, we could have F be our point on the bottom. And I'm about sick of drawing these triangles, so fortunately our question is coming to an end. Okay, AB, we could have AC. It's so much tedium just drawing the dots. Especially when I already know the answer. Here's our one triangle for this area. or for this case, and the other two are going to be right angled. B, C, and F. If you have a protractor, you could, for example, a protractor and a ruler, on the picture they provide, you could draw in A, E, C and double check that, yeah, you get a right angle right there at E. That's why a protractor is a good thing to keep with you for these exams. You know, not everything's drawn to scale. That's another reason I use graph paper. If I bring graph paper as my scrap paper to the contest, I know that these are going to be right angles, whereas maybe on the contest questions, they haven't exactly got right angles here. Who knows? Just little things to keep with you. Protractor, ruler, graph paper, those are excellent things. So in total, there are 4 non-right angled triangles. So 4 non-right triangles. And that is an answer of, I think it was B, was it? No, E. E. Okay. And even if we were a little unsure, we know that there's definitely at least 4. Now let's take a look at the possible answers. With a question like this, once we have 4 of them, we know the answer can't be 1. We've already found 4 different ones. But there's a possibility we missed something in our counting. So at this point, we've narrowed it down, at least, if you don't have confidence in our answer, to a guess between 4 and 6. And on a contest, I completely recommend, if you can narrow it down to 1 out of 3, or really, what would be really nice is 1 out of 2, take that guess at the end. If not, if you're still staring at a blank question, you've done no work, you can't narrow it down between any of the 5 answers, leave it blank. If you leave a question blank on these contests, you automatically get 2 marks. And that's better than your odds, your average point outcome than you would get if you just guessed. But if you narrow it down to 1 out of 3 or 1 out of 2, that's great and that's fantastic, and that's something you should take a guess on. Okay? But we're pretty confident in our answer 4, so our answer is E. That's what we bubble in, and we're done question 20, and now it's on question 21, the very first question in part C. So have a gander at that if you haven't already. Take a look at all of part C, try them for yourselves, and I'll meet you in the next video for our very next question, question 21.